All right, welcome to Bell Work, week 6, day 2. We have a rectangular block of an unknown metal, has a mass of 255.01 grams. The dimensions of the block are 5.1 centimeters by 3.2 centimeters by 5.91 centimeters, and you are to calculate the density of the block of metal. So what do we need to know to calculate the density of this block of metal? Yeah, we need to know mass over volume, because density is a relationship. It has a mass to volume relationship, right? So that's what we're looking at. So do we know the mass? Yeah, what's the mass? Yeah, 255.01 grams. Do we know the volume? Well, it's not quite as clear as the mass is, right? Because we have 5.1 centimeters by 3.2 centimeters by 5.91 centimeters. And so we know that volume equals what? Length times width times height, right? And so we can assume that those values are length times width times height. Do I need to know which is which? No, not at all. So all I got to do is plug those in, and I get 5.1 centimeters times 3.2 centimeters times 5.91 centimeters. All right, and so we multiply that out. What do we get? 96.45. Anything else? 1, 2. Okay, that's good. What's my unit? Centimeters cubed, because I took a centimeter times a centimeter times a centimeter, which is centimeters cubed, all right? So they don't cancel when you multiply. You multiply them, right? So it's centimeter times centimeter times centimeter is centimeter cubed. All right, so how many sig figs can we have in my volume calculation? I have, who said 5? Why 5? Oh, you just said, someone said 5 first hour too. Say what? No, we're looking at just the volume calculation. 2. So we're going to look at that. Yeah, it says 96.4, right? So that we go 2, 1, 2. We look at the third one. It's a 4. What are we going to do? We're not going to keep it. We're going to round up to 97 based off of the 4. Yeah, you're going to drop that whole section right there, right? And so it's going to become 96. Let me change that back to a black color because it looks like I'm doing something wrong. 96 cubic centimeters. I know it. It's kind of a messed up 6, but we can fix it. All right, is that better for you? All right. Yeah, 7th hour, I played this video for them as their bell work. That's all they get. I stopped talking. I just play this for them. And so they'll appreciate me fixing that and you saying something, because they said the same thing. What? Just as you did. All right, and now it's fixed. You're welcome. All right, so what are we doing here? What is the next thing? Divide. So we take 255.01 and we divide it by 96, and what do we get? 2.656. What's my unit? Grams. Cubic centimeters. Yes. All right, the C stands for centimeter. All right, that's what it stands for. So, and there's 3 of those multiplied. So that's why it's cubic centimeter. 2.656 cubic centimeters. Now, how many sig figs can I have? 2. 96 has 2 sig figs. It's the fewest in the problem. So now I look at 1, 2, go to the 5. What am I doing with that? Rounding what? What am I rounding up? The 6? Yeah, so it becomes what? 2.7 grams per cubic centimeter. And there you go. That's our answer there. So we need to know that answer to do problem number 2. All right? So in problem number 2, it says if you have a block of metal of the same element, and if it's of the same element, that means it has the same density. That was placed in a graduated cylinder, and it is and it displaced the water by 2.3 milliliters. What is the mass of the metal? Hint, you need to use the answer from problem number 1. All right, so what are we trying to find here? Yeah, we're trying to find the mass because it says what? What is the mass? So we need to know the mass. So our problem is going to be equals blank. What's a unit of mass that we might use? Grams. So what do we know? We know the density, and what else do we know? We know the volume. So we can convert 2.3 milliliters, our volume, to grams using the density as a conversion factor, right? Because our density from our problem number 1, we said is 2.7 grams for every 1 cubic centimeter. Do you see that? Now, what's wrong with using that as a conversion factor? Do you see anything? Do you see anything that's weird about that? Like, what is my unit of volume in my conversion factor? Cubic centimeters. What's my unit of volume in the problem? Milliliters. Is that an issue? Do I have to convert? Yeah. You know what's nice about that, Sienna? You know what's nice? Is that, and I'm sorry, your name is on YouTube forever, but not your last name. So 1 cubic centimeter is equal to 1 milliliter. Is that a tough conversion? So could I just as easily say that this is 2.7 grams per 1 milliliter? If 1 cubic centimeter equals 1 milliliter? Yeah, you can. So there is no problem really, because the conversion between cubic centimeters and milliliters is an easy one. It's a 1-to-1. All right? And so all I have to do is start my bracket. Now, the reason I'm using a bracket here is because I don't know the mass, right? Now, you can solve this algebraically. You can take your density formula, and it's just mass over volume, and you can solve this by multiplying by volume, and mass is going to equal volume divided by density, or volume times density. All right? But we're using dimensional analysis to solve this. And so to use dimensional analysis, we're going to start with what is known. What is known? 2.3 milliliters. And then we use our conversion factor. What unit goes down here? Milliliters. What unit goes up here? Grams. And so what you see is you have 1 milliliter is equal to 2.7 grams. We already have G there. So 2.7 grams. All right. So 2.3. What are we doing with our values there? We're multiplying. All right. So what's 2.3 times 2.7? 6. Oh my goodness, I can't get away from this red pen. 6.21. And what's my unit? Grams. It's the unit of mass. Now look at this. Milliliters and milliliters divide out. Do you see that? And so you're at 6.21 grams. Now how many sig figs can I have? 2. So I'm going to just count 2 sig figs. 1, 2. Look at the third. Am I rounding up? Am I rounding down? Or am I keeping it the same? Keeping it the same, but it's going to be 6.2, not 6.21, because that is the number of sig figs. So 6.2 grams. Too easy? Now, what if I want to know? What if I want to make sure that's the right answer? Can I do something to make sure that's the right answer? Yeah, I could plug it into my density formula. So here's density is equal to mass over volume. My mass is 6.2 grams. My volume was what? 2.3. You see that right here? 2.3. And then my density was 2.7. So if I get 2.7, that means the mass I calculated was correct. Right here is your volume. You see that? That's where I'm getting 2.3. All right, so what does that come out to be? 6.2 divided by 2.3. Comes out to be what? 2.69, and if we use 2 sig figs, it's what? It's 2.7 grams per milliliter. Isn't that what we said our density was? So our mass must be correct. Do you see that? So there's always a way to check. Anyway, that's all I have for that. That was week 6, day 2. Thank you for watching, and tell your friends. This is an amazing